Hey, we're back now with Rufus and our video on indirect measurement. I'll give you a moment to read through there. You go ahead and pause the video until you are finished reading and then hit play when you're done, and then I'll be working through here. Okay, so Rufus is going to he's going to try to jump over this tree. I applaud Rufus for trying. I wish I was there to watch. And I'm sure it's going to be a fun time, at least for everybody watching. So, anyways, if we look at some important information, well, this mirror down here, that's really important because this is reflective property. Now, remember, reflective is not the same as the property that we've been using in geometry called reflexive. Okay, reflexive property says like angle A is congruent to angle A. Reflective property, it's like when you look at a mirror, you see a reflection. So this reflective property of mirrors will tell you that this angle 2 is congruent to this angle 1. And so now, knowing that this should be a right angle, and knowing that this should be a right angle, we know that all right angles are congruent. And so what do you know about those two triangles there? You should know that they are similar because of the, which similarity theorem? Angle-angle similarity theorem. So since those are similar because of the angle-angle similarity theorem, we could just go ahead and take some of the measurements that we know, plug them in, and then the corresponding sides should be proportional. So what's some of this information that we know? He placed a mirror on the ground 30 meters from the tree. So 30 meters from the tree, we're going to write 30 meters there. And then Rufus stepped back until he could see the top of the tree in the mirror. He measured his distance from the center of the mirror to be 5 meters. So we're going to plug 5 meters right there. Rufus weighs in at 225 pounds. He has a height at his eyes of 2 meters and a reach of 103 centimeters. 103 centimeters. I don't know if you guys know much about boxing, but a reach of 103 centimeters. Good luck trying to get inside on that guy. You're probably going to get your face pounded in a little bit. You got to be quick. Fly like a butterfly. Sting like a hornet. I think hornets sting a little stronger than bees do. Anyways, getting back. The important information is not his reach and not how much he weighs, but so much his height. And remember, this is height at his eyes because I know this triangle looks like he's going to the top of his head, but when Rufus is looking at the mirror, this is going to his eyes and not the top of his head. So the height at his eyes is 2 meters. So if we look here, we could figure out how tall that tree is. We know we want to find the height of the tree. So let's go ahead and set up proportions. Looking at the right triangle, the distance is 5 meters to the mirror. And looking at the left triangle, from the tree to the mirror, 30 meters. On the right triangle, the height to the eyes is 2 meters. And on the left triangle, the height to the top of the tree is h. We don't know what that is. And so from this point, we just do some cross multiplication. 5 times h, so we have, let me do something here before we do that. I see meters on top and meters on bottom. I'm going to go ahead and cancel those off. And now 5 times h is 5h. And 30 times 2 meters. 30 times 2 is 60, so that's 60 meters. How do we get h by itself? Divide by 5, divide by 5. That leaves us the height is equal to 60 divided by 5 is 12 meters. So the height of the tree is 12 meters. What do you think the chances of Rufus jumping over a 12-meter tree? I think his chances are pretty darn good if somebody cuts the tree down first. That's what I think. So, a couple things you learned here. The reflective property of mirrors says that the angles coming out of the mirror are congruent. And don't forget, this is a measurement to the eyes. You're going to need to know this stuff. And I think that's basically it. Everything else you should already know. Okie dokie. So, that would be the Eiffel Tower in Paris at nighttime. That's what it looks like. It's a nice little view. Looks like you got the moon there. That would be the Eiffel Tower in Paris in the daytime. And this brings me to a good point. There was a pilot, came on the loudspeaker of the airplane. He said, "Thank you for flying with us, ladies and gentlemen. We have ascended to our altitude of 35,000 feet, and the plane speed is going along at 700 knots. I do have some good news and I have some bad news." The pilot then proceeds and says, "The bad news is we're lost. The good news, we're making good time." So, I thought this was a pretty good time to share that little story with you. We're making pretty good time. Oh, here's an example, just like the last one. What I would like you to do is I would like you to do this one on your own. Pause the video. You may want to draw a couple triangles. And then as soon as you're finished with your calculations, check your calculations with mine, and then we can go from there, just to make sure you're correct. So go ahead and pause the video. All right, I'm looking here. Emmanuel, she's trying to get the height of the Eiffel Tower. Let me move it down here. All right, so she's trying to get the height of the Eiffel Tower. Let's plug in some numbers that we know. She placed the mirror on the ground 500 meters from the center of the base of the Eiffel Tower. She stepped back 2.75 meters. Until she could see the top of the tower in the mirror, and her eyes are 1.8 meters from the ground. 1.8 meters from the ground. What is Emmanuel's calculation of the Eiffel Tower? And I'm trying to find the height of the Eiffel Tower. So let's go ahead and set this up. We're going to say 2.75 meters divided by 500 meters. That's going to be equal to 1.8 meters divided by h. I know I can cross off meters on the left side there, leaving us to go ahead and do our cross multiplication. 2.75 times h is equal to 500 That's going to be equal to 500 times 1.8. I'm getting 900. Now that was just 500 times 1.8 meters, so that's going to be 900 meters. So now how am I going to get h by itself? Divide by 2.75, divide both sides by 2.75. 2.75's cancel, leaving us h is equal to 327.27 meters tall. 327 meters tall. It's the Eiffel Tower. Has anybody seen the Eiffel Tower? Has anybody been to the Eiffel Tower to just Paris, just to hang out? Anybody? No? Nobody? Man, it's awful quiet in here today. Well, if you guys would like to share your Paris story, let me know, and I'd be interested, more than interested, to hear about it. So, this is the calculation for Emmanuel to determine the height of the Eiffel Tower. All right, let's just say one day you and your favorite horse are out on the range, trotting along. Your favorite horse, Lucky? Yeah, your favorite horse is Lucky. And you come to this little river here, and it's like, doo 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 doo. Hey, it's a river. We can cross. Well, you need to get over there to those people, because those people are your friends. Oh, the river's just flowing nice. It's flowing nice, not too rough, not going to sweep you down the river, not going to make you drown. But once you get closer, you notice these little things running around. Oh, those are neat little fish. Those are really neat. They got bright speckled flakes on the sides of them. There's a bunch of them. Neat little fish, neat little fish. Well, when you go to step into the river, look what happens to these neat little fish. Whoa. They get hungry, feisty, and they're ready to eat. Lucky's not going in there. Lucky says, no way, you're on your own on this one. Well, considering you've taken this class, you can do things like this. Well, you're going to figure out the distance across the river. Why are you going to figure out the distance across the river? Is because you and Lucky are going to go up on the hill, tie a zip cord, a zip line, and yes, you're going to be able to tie a zip line because that's in the pouch strapped to Lucky, and you're going to zip line across the river. Now, you may or may not take Lucky with you, and if you don't need to take Lucky with you because, like, say, you're just going to this little camp to hang out with these people, and then you're going to be leaving, you zip line back across, get on Lucky, and go home. So Lucky doesn't really need to cross the river. But it would be kind of funny to see you try to strap Lucky to a zip line and get him across the river, because that is your favorite horse. So basically, let's look at what we're doing here. Okay, what you've done is you found a point on the river. You've looked straight across to, like, say, a different point across the river, and you kept looking out straight from there. Now, I kind of did this backwards here because you're not on this side of the river. You're actually on this side of the river. You're on this side of the river because how else would you be able to get this measurement of 8 feet? So you got in a straight line and you looked in a straight line and you said, hey, this is 8 feet. You're able to measure that. And then what you did was you placed a rock here, placed a rock here, you placed a rock here. That way you could have your straight line. And then you walked at a 90-degree angle back to point O, and you walked 6 feet. Now once you did this, you're able to look from point O down through this rock that you've placed along the riverbank to pick a point A down here. I don't know, it's some sort of tree or something. Who knows what it is? Maybe it's like a hut. Maybe it's like your favorite hut that you like sitting at when you go to this little camp. So you basically have now created this triangle here. Well, you ask, well, how am I going to get this 48 feet? Well, what you do is you go back to point C and you walk out to here until you get directly across the river from point A. And then this distance, 48 feet, is the same as that distance of 48 feet. Okay, so I know it takes a little bit to set up, but I can tell you, it sure beats this. I'm not swimming across that river. Lucky said there's no way he's going across the river. If you want to go across the river and make it, good luck. I'm doing a zip line. So let me get rid of some of this other stuff that we don't really need here. Now we can do some calculations. Now, why does this work? Well, we do know that these two angles here, those two angles there, they're going to be congruent. Why are they congruent? They're congruent because they are vertical angles. And since we have right angles congruent, vertical angles congruent, we know that through the angle-angle similarity postulate that those two triangles are going to be similar. Well, since those two triangles are similar, what we can do is we can set up some proportions. Or if we can set up a proportion. We put 6 feet. 6 feet on top, and 6 feet is corresponding to 48 feet. And then we look at 8 feet. Since 6 feet was from the top triangle, 8 feet is also from the top triangle. That means both of them go on the same level, top of the fraction. And then what is this here? Well, this is the distance across the river. We're going to call that D. Well, I want to do a little bit of reducing here. I see feet on the top and feet on the bottom. Cross those off. And how about 6 and 48? Well, 6 goes into 6. I'm reducing each one by 6. So 6 goes into 6 once. And how many times 6 go into 48? That is going to be 8 times. And I like the way this looks a little bit better than if I were to cross multiply 8 times 48. That's going to be a larger number than what we have now. 8 times 8. So now let's go ahead and do our cross multiplying. 1 times D, that is 1D. And 8 times 8 foot. Well, 8 times 8 is 64, and then we have the unit of feet. So the distance across the river is feet. And I know you can hear in the background, Lucky's back there clapping for you with his horse hooves. He's back there sitting in the shade waiting for you to do your calculations, do your walking around, looking at rocks and looking at trees and enjoying the moment. And then now it's time for you to go ahead and zip line across this to hang out at the little village with your friends. That'll be the conclusion of our video here on indirect measurement. You should keep your notes because there might be a time when you're going to need these. Thank you.